Okay, yes, we welcome you to PSSB, Physical Sciences Silver Bullet. So we are looking at this case today. It says Martin applied the force of 300 newtons to the lawnmower of mass 70 kilograms. The force acts at an angle of 30 degrees to the horizontal. We have it here. The lawnmower undergo displacement of 15 meters. And we have a coefficient of kinetic friction. So what do we do here? Okay, we are looking for acceleration. Okay. So what we are going to do, we are going to use Newton's second law. It says F net is equal to ma. So we know the mass. What is stopping us to get acceleration is net force. So how do you get net force? You come to the free body diagram and you indicate all the forces which are acting on the body. This body is on the ground, so it has Fg being opposed by Fn. We have to remember that our applied force is acting like that at an angle of 30 degrees. But we must not forget that for free body diagram, all the forces are drawn away from the body. So being a vector quantity, this force, without changing magnitude and direction, it can be put here. So this is our force applied. It's in the same line, so direction is the same and is of the same magnitude. So what we have here is 30 degrees. After putting this force here, now this one, we don't need it anymore. It has been represented. So what else do we know? We're having coefficient of kinetic friction here. So which means that it means there is friction force. We must not forget that this body is moving this side because of this applied force. So our friction force opposes that motion by being there. So that's what we are having. What is our next step? Our next step is to have the components of our applied force. Our applied force has this component, which is Fa sine theta, and also it has this component, which is Fa cos theta. So when you have the components, what happens? When you have the components, it means that our force is now represented, is gone. So we take it out. So now what we are having are those forces all together. So what do we do? Remember, our intention here is to look for net force. So you come and say net force is equal to sum of these forces, but these in equilibrium. So we are going to say net force is equal to Fa cos theta cos 0 plus Fk cos 180 degrees. Okay, what do we do? What do we have here? We are going to say F net is equal to Fa cos theta minus Fk. Okay, so we know Fa, we know theta. What is our problem? Our problem now is Fk. So how do you find Fk? You have to remember that Fk is equal to mu k Fn. So what is our Fn? Our Fn, remember that vertically this body is in equilibrium. It is neither going up or not going down. So the meaning of that is that the sum of forces upwards are equal to the sum of forces downwards. So Fn is going to be equal to Fa sine theta plus Fg. That's our Fn. And so when you come here and you know that our Fg is mg, you must not forget that our Fg is mg. So what are you going to get our Fk? Our Fk is going to be equal to mu k, then into Fa sine theta plus mg. Okay, you can find everything here is known. You can find that one and find this one and get the answer. Let's try to substitute in and we see what we get. Our mu k is known and is 0.3. Our force applied is 300 newtons. Sine what? Sine 30 degrees plus what? Plus 70 times 9.8. What you get there will be our Fk. Okay, let's see what we get out of that. So now we have our Fk, and after having it, so what is going to be our Fnet? Our Fnet, remember Fnet from this expression here. Fnet is equal to Fa, which is 300 cos 30 degrees minus Fk, which is 250.8. What is the answer here for Fnet? Let's find out. So now we have our Fnet as 9 newtons. So when you substitute it in our primary equation, we're going to get Fnet equals to Ma, and where this one gives you 9, which is our Fnet, equals to 70 A. So our acceleration is going to be equal to, let's find out here. So that's what we get. We get our acceleration as 0.129 meters per second. Okay, that's that. Let's see what comes next. Yes, then we close this video with this simple question. It says, calculate the change in kinetic energy. So we are going to maintain this data because it will make our life simple. What do we do here? We are going to use work energy theorem, which says work energy is equal to delta Ek. But we have to remember that one is equal to Fnet delta X. Okay, So if our F net is known, so what are we going to do? We're going to write the expression and we say F net delta X is equal to delta EK. Okay. From here, what do we know? We can see that we know our F net or net force. We have it here. And what else do we know? We know our displacement. It is here. So what are we going to say? We are going to say our F net is 9 and our displacement is 15. That is equal to delta EK. Okay, what do we get out of that? Let's see. So this is what we get. We get our change in kinetic energy as 135 joules. Okay, thank you for your time. We appreciate it. Thank you for your subscription. If you haven't subscribed, please do so. Yeah, we meet again. Thanks very much. Bye-bye.